Hopefully you've had an opportunity to try drawing Lewis dot structures for these three example molecules. I'm going to walk through my version of doing them here for you. So let's start with the first one. We have a phosphorus and hydrogen atoms, and we've got 3 hydrogen atoms. Each hydrogen atom has just 1 valence electron, and we'll need 1 bond. And phosphorus is in group 5. That means it's got 5 valence electrons around it. And so it's going to need 3 bonds because it has 3 unpaired electrons. Because phosphorus needs more bonds than hydrogen, I'm going to start and put it right in the middle. And I'm starting with my electron dot symbol. And I have 1, 2, 3 unpaired electrons, and I have 3 hydrogens that each need 1 bond. So that matches up perfectly. I can place my hydrogens at each of these unpaired electrons around the phosphorus and connect them, just like connect the dots. And I have a complete Lewis dot structure. I can double check it too. My hydrogens each have 1 bond with 2 electrons in it. That equals 2 total electrons, satisfying its duet rule. And my phosphorus has 3 bonds with 2 electrons each and 1 lone pair with 2 electrons. That's a total of 8 electrons, so the octet rule is satisfied. So this is a reasonable Lewis dot structure for phosphorus trihydride. And you'll notice it looks just like NH3 that we did earlier, right? And it should make sense because nitrogen and phosphorus both have 5 valence electrons and they're in group 5, so they'll bond very similarly to hydrogen. Let's take our second one now. This has a lot more molecules in it, or a lot more atoms in it. It's a larger molecule. So I've got 2 carbon, each with 4 valence electrons, which means they each need 4 bonds. I have 6 hydrogens, that's a lot. They each have 1 electron and need 1 bond. And I have 1 oxygen, which has 6 valence electrons because it's in group 6, which means it will need 2 bonds because it has 2 unpaired electrons. Or you could take 8 minus the number of valence electrons. 8 minus 6 is 2. It'll need 2 bonds. So this carbon has the most bonds, needs the most bonds. So I'm going to put it in the middle. And I have 2 of them. So I'm going to start with both of them in the middle and link them up. And so I can connect these 2 unpaired electrons on carbon and form a bond between them. Now I'm going to place my oxygen atom next because it needs the second most bonds. It needs 2. And I'm just going to place it on the end. And I'm going to match it up with a carbon unpaired electron with one of my oxygen unpaired electrons and connect the dots to form a bond between the 2. Okay, now I'm going to count up my unpaired electrons and compare it to the total number of hydrogens I have. So I have 6 hydrogens that can form 1 bond, and I have 1, 2, 3, 4, 5, 6 unpaired electrons. So that's the same number. I don't need to form any multiple bonds because of that. So I'm going to place my hydrogens lined up with these unpaired electrons in my structure and connect them to form a bond. And I have a reasonable Lewis dot structure. Each hydrogen has 1 bond with 2 electrons. That satisfies its duet rule. Each carbon has 4 bonds, each with 2 electrons. That satisfies its octet rule. And my oxygen has 2 bonds, each with 2 electrons, and 2 lone pairs with 2 electrons. That's 8 again, so that satisfies the octet rule for oxygen. And this is actually the structure I made ethanol. And this isn't the only possible structure. You can choose to do it a little bit differently. So an alternate solution to number 2 would actually be, instead of ethanol, an ether, where I have a carbon bonded to an oxygen, and that oxygen's bonded to another carbon, and each carbon has 3 hydrogens bonded to it. For Lewis dot structures, there's often multiple correct or reasonable answers to a chemical formula's interpretation into a structure. Okay, so that's number 2. Let's go on to number 3. Carbon dioxide. So I have 1 carbon, and I have 4 lone pairs around carbon, so it will need 4 bonds. And I've got 2 oxygen, each with 6 valence electrons. And so to reach an octet, it will need to share its unpaired electrons to form 2 bonds each. So I start with carbon. It needs the most bonds, and I put it right in the middle. And now I have my 2 oxygens that each need 2 bonds, so I'll place them next. And connect up where they connect up, where I pair up the unpaired electron with one of the carbon unpaired electrons. Okay, I'm out of atoms, and I still have electrons that are unpaired. I've got 2 on carbon and 1 on each oxygen. So at this point, without more atoms to place, I need to form multiple bonds to be able to solve this structure. I can't leave unpaired electrons unless I know I am trying to form the structure of a radical, which is not actually in the scope of this class. So I'm going to match up the electrons on 2 adjacent atoms. So between this carbon and oxygen and this carbon and oxygen. And I just connected the dots, and I'm going to redraw it. But it means I'm going to have a double bond between each of my carbons and my oxygens. So if I redraw this with 2 bonds between carbon and oxygen, and then come in and put in my lone pairs for oxygen again, I'll have a complete structure. And my carbon has 4 bonds now, each with 2 electrons, so that satisfies the octet rule. And each of my oxygens have 2 bonds, each to the same atom, but it's still a shared 4 electrons, each with 2 electrons, and it has 2 lone pairs, each with 2 electrons, so that has 8 electrons total. So both of my oxygens satisfy the octet rule too.